Okay, record start.
All right, so from yesterday, we covered this DERMS awareness, hosting capacity, active network management, and what flexibility. So this one, I think we are one day ahead of this schedule. So this was supposed to be tomorrow probably, but like, yeah, let's see if we can maybe finish today as well, if we can, and we spare. So it's a DMS load flow state estimation tuning, and then we discussed about forecast. So these are the module, near term, short term, medium term. I think we just generally do all of this. Then they look ahead and how does that look ahead works, and then we can still some questions and answers. If something we didn't cover, we can go back and see like open discussion between open discussion. I go to the software mainly to explain like more about tuning. I had some presentation, but it was on the, I guess, load flow last slides. In the high level, so tuning, what is tuning? Tuning is the process that we want to make sure the data, static data and the dynamic data are good enough for load flow and state estimation to work properly and show reasonable results. And then when we get that, like all other applications that they are using, will be then providing acceptable results or reliable results, let's say. So the first thing is topology. So we need to make sure we have the correct topology. So like, and then switches and they have the right status and all this. We have enough like the data in the model. For example, we talked about the load profile, so load profile, how you prefer the load profile. And then we just do load flow tuning first and the state estimation tuning. So this is kind of mandatory for these applications, FlizzerLar, load relief and forecast. And if we use load flow, right? So if you say model based, if it's not model based, then okay, so this is not in question. If some softwares, they wanted to do the LV, for example, they want to see what is the voltage, then extra steps needed because VVO, if you want to engage VVO to mitigate the voltage, probably you want to see what will happen in the LV, what is the voltage. It's a bit more complicated and more basically efforts needed to be done because the impedance data is normally difficult for many customers to get. So then it's the next basically a step. So that is. The basically load profile. Load profile. What is it's kind of, we have a software basically dedicated to create load profiles. We provide some historical data, such as P or Q over the time, similar to the forecast that I said. So that's one of the reasons I said we need to have historical data. And also weather historical data, and defining season, day types, and temperature range. Seasons, why we can in some, because each country's seasons, definition of seasons are different. For example, if in Europe, so we have like 4 seasons. In Australia, just maybe 4 seasons as well. In some areas, some area maybe just 1 season is enough. Some area maybe 2 seasons. Like I don't know if it's very different during the monsoon or non-monsoon, depends the temperature. So we can start with the simple one, which is maybe, I don't know, in your country, the temperature around the year is similar. And because, yeah, I think maybe just one season would be enough. And then the day types we have, like, for example, we can say, okay, weekdays in some countries, like, for example, Muslim countries, they have Friday, like half a day, and, you know, we can define which day is a public holiday. So here is just Saturday and Sunday is public holiday in general. So we can have 5 working days too. Okay. And the temperature range, again, this is maybe it's very important when we have very different climate. Like, for example, in Australia, there are some cities in the winter, it's very cold. So your high load in the winter is in the winter actually. Some of, and then you want to have a different range and different profile for winter versus like other temperature. If it's too hot, then your load is high because people turn on air condition. So normally we define, like, based on the customer, few different temperature range. But I think in your case, temperature again around the year is kind of like similar, like
The lowest is around 16 and the highest is maybe 40 only.
yeah, okay. But maybe, yeah, maybe we can use, I mean, like from start, we can use one and see if it results are good. That is good enough. So we get that data. So why we get this temperature range and weather data? Because the load, it depends on the day, right? It depends on the time, like, and depends on the temperature, for example, or humidity. I don't know. Like, we can use this all of this data to like in the model, it goes and analyze it. It's kind of a machine learning kind of algorithm, and then as an output, it gives you a curve. So this curve is the actual measurements. You got this like a lighter blue, and like you see, it kind of average goes and creates this dark blue one. So this dark blue will be representative of those, because, you know, if you look at individual one, it might be different, but this is good enough. So then this will be used by the application. Yeah. If you don't have this, I mean, like, to start with, if you already have like this curve already from your older studies, from your own data, we can just load it for that to start with. And when you have historical data, you give a historical data, we can just treat it. Yeah. So if we can, I mean, we can use this load profile generator is optional too, like I'm saying. Yeah. And it's kind of offline. You do it once, and then you create the profile and use it. Maybe you want to update it next year to see if the load change, pattern of load change. If the pattern of load doesn't change, so probably you can still keep using it unless, or if you think it might need a bit to change. Okay, so that's the load profile generator. Okay, this is implementation process. This implementation process, maybe it applies to many of these modules that we provided. We need to see, okay, what is your goals, what you want to achieve. Why? Because, for example, we said, okay, if you want to go VVO on the low voltage, we need to know what we're going to go. So your goals here, I think, is DERMS clear. So we want to see use the batteries and solar to mitigate, or not, I mean, like, see what happens. And then we do modeling analysis and stuff like this. A model tuning is a little bit iterative. So you fix this, you put it in the system, see if it works, if the results are good. If it's not good, then we do another round of processing. It might be one loop or 2 loops. And from time to time, maybe when you have the system on real time is working, maybe from time to time, you need to do like a checking that if something is not working, this you will speak. And yeah, so defining pilot area, I think in your case, you already defined, so we know that which area we're going to work on. So, so this is okay. Yeah. Let me connect to the. I disconnected. So.
Monitoring is quite the same. We call it also like training, model training.
Model
Is
training.
it different? Because I see in your slide you use the model tuning.
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 Not training.
So
Yeah.
is this different with the training? Because you have to use like some AI algorithm or something like that, or how could you tuning the model?
Yeah, it's no, this tuning model is kind of a human like process. The one that I said is kind of like a machine learning is this load profile generator. You get the data, a lot of data, and then it will kind of find the best adoptable this one. So from like machine learning, from all of this input creates this dark blue one. So this is the machine learning part of it. But the rest of it, like this process, is kind of like operate like an engineer need to look at the results and yeah, it's engineer's work, yeah. Okay, so for this tool, I forgot. Sorry, for this tool, I think I'm not. I did. This is. I forgot. Missed this slide. But when you open that load profile generator, this is kind of data need to add seasons, starting date, stopping date, which days is I explained it verbally anyway. So, and then if you have some public holiday, you can put it there, and this is the temperature range. So, yeah. This I explained it, but I couldn't show that. So I connect to real time, and I can connect to the simulator. So network simulator, the real time already connected. So this one is the second. Okay, so I close the things that we don't need here. It's from yesterday. Oops. So here, like the network simulator, I'm opening, it's for OTS as well. So you can have different modes. So manager is like you can do everything. Editor, they can do certain stuff. Executor, less stuff. So I think if you have 3 people, you can use that system. This is kind of a new functionality, but normally I use the manager because it has the most privilege. Okay, so this is all right. What applications we have? All right, so we explained about load flow results and stuff like that, but before starting the like a load flow process, I mean, it's part of actually part of load flow process. We have this module called model readiness. Is the model ready or not? So let's see like it says everything is bad here, but okay. Maybe I go to one area like that I kind of like want to see. Yeah, so this is kind of refreshed here. Like you can see, let's go to maybe one feeder, maybe. So this one evaluates for different factors, and the 9 like is highest number, and like 0 or 1 I think is the lowest number. So and then based on all of this, it gives like an index, like kind of like based on all of other this. So this one, if we go up a little bit, substation loading mark. So if for example the results, like you see a lot of loading on the network, and maybe that's because your calculation is wrong, or maybe the ratings is wrong. So if you have a lot of problem with that, you're gonna get a bad score. So here, you got a good score in actual. And yeah, so because remember we were showing, if I go to that MS04, let's say, so I change the coloring to relative load. You see legend, if I turn it to legend, you see if these values are all below the mark that I have, that means the loading of my system is probably very good. So it's unlikely that I have a problem with the rating of this. So that's checking this section loading, right? So it's 9. Substation loading is, for example, the elements on the substation, so like transformer and stuff like this. And voltage profile, it says 9. So like, for example, I go here and right click on this feeder, some of the elements. I think I need to zoom in a little bit, but okay, so voltage profile. If the voltage profile is between the values that we want, like it is marking as good. So here you have very low here and very high here. So because of that, it thinks the low voltage profile maybe need to be evaluated and checked. So those type of things, it's in high level. You can see in generation production. This one doesn't have any generation, so it shows unknown. Consumer consumptions also shows good, because like like if you run load flow and show the consumptions, the ranges are reasonable. Yeah, this one is one tool. I personally don't quite use that tool. It's a little bit like when you have the network tuning, you can just from time to time look at that. But there is another tool called network checker. Okay, so network checker, you can choose the area of your interest. Like for example, I select this one, drag and drop. And then I go here. So the first one is topology validation. And let's say I want to do load flow. So I want to just look at MV first, and we can just choose for this. I can have like number of messages. I just increase it just in case if I have too many data. Then I go to advanced. So the first one is topology. It checks for all of this all of these items. So for example, for energization unknown, I think we talked on like one of the days that like unknown is not good because it might be earth or not earth. So it checks all of this data. It checks for catalog data as well to see if the catalog data is good or not good. So so you can say, look at section meters and anything below this market or not. So we don't select this. We just want to see check topology above consumer transformer. Consumer transformer is the basically, I don't know in your terminology, maybe you call it distribution transformer. Is border between MV and LV. Okay, so if you want to just check up, you can check that one, and you can select bottom. You can select and so on and so forth. There are lots of items here, and if you want to see, for example, catalog data for switches, you can see if you select. Okay, so let me just select those two as well. And then the other one is for load flow. Okay, maybe just we do one by one. So we just unselect load flow, and then I run it again for that. So to see what kind of information we are getting. Okay, so it ran the study, and when we look at the report, it gives messages. So firstly, it says, hi, this one is de-energized. You can find out, okay, is it really true or not true? Is, for example, if it's a manual switch or it just gives you like where those are. You can just double check with another system if you have another system to see if it's correct or not correct. Then this one, it says cross-section does not correspond to the value of R and R0. So remember when we were talking the cable catalogs, we said, okay, we need resistance and yeah, R and R0 is zero sequence resistance. So this one is also, it compares this to the conductor type, like you say, is aluminum, and the cross section. So it does calculate and and compare these two with each other, and it says they are like do not correspond to each other. So this is in case you have both information and you want to check, you know. Do you get what I mean? Like it just,
Yes.
because the attributes are independent. You can put R as something, and you can put I don't know, cross section or something. It just double check that is that close enough to that or not. So these are
So if they can double check, so why don't they like just put the R number and R0 number for us? Because we have the length, we have the type, like the aluminum, right?
yeah. If
We
you know
have
the type, so if you have all four data, so you have, let's say you have type, you have cross section, right? You put that, and you have R from also your system. You put all these three, let's say, into the system. They should match. kind of, right? Because for aluminum cross-section X, you normally get R like that. And it uses aluminum property with that cross-section to calculate R. If you have 3, if you don't have cross-section or aluminum, then you get this message and you just ignore this message because you are not sure about this. Or either way. Yeah. So this is kind of like helps you like to find any issues. This one, the next message. So you get a lot of this message, right? So, and then it's for different part. Then I can also filter out like something and just check for the rest. So this one, it says consumer plus is blank. There is no consumptions under this. Okay, what does that mean? Like if I go here, it takes me to this consumer or distribution transformer, whatever you want to call it. And if I go to geographic, you see there is no consumer, no generator connected to this. It's kind of weird because you always, when you have like another one, let's say these are different types, but the color, like for example, the shape is based on like, for example, Qs or I don't know, air, like it's installed on the pole. Okay, but these and these are the same kind of objects. You see that this one has consumer connected to this. This one doesn't. It means that probably something wrong, right? Maybe you missed some customers here. So that is this. And then yeah, so if you get too many messages, you can just filter and see issues. Some of them are there. We have like a severity here. Error type connectivity. So you can say error type. What is error type? And I think we have severity. Where is the severity? Maybe. Okay, they changed. Okay. I think they all the version they were calling this severity or something. Okay, that was like a base one, right? So this one, I like this one, and to some extent, because it helps find the issues. Now, if I go to the load flow, let's see what other parameters we check here. So overload, you remember I was telling you about overload, the other one. So if it's normally, why do we have this? Because let's say you have a conductor there and it says 100 ampere and load flow results 120. So either load flow results are wrong, right? Or the rating is wrong. Otherwise, you have burnt that section and you have outage, right? So this is kind of like, yeah, checks these two together. Load flow quality, okay, questionable. The same for transformer, it checks the data. So let's do like very quick one with this one, and overload for transformer, overload for sections. Check about grounding. The also like the configuration is also important, like what configuration you could have. Okay, I select all of this now. Okay, so just to test and run. Or maybe I should have removed the first one. Okay. Okay, so because I just want to see what is the problem with this, right? So oh, there is no problem with that. That's why we don't have any entry there. Okay. So maybe I should make something wrong and show you how does that work. But okay, so maybe this is a network simulator. So I artificially increase the load to I don't know, 250%, let's say. Let's see if it impacted that. Yeah, I think you see this value is all raised, and we see a lot of arms.
Alo, em nghe đứa này. Đang nguyên tuần này em dính học của hết luôn.
Maybe it's not enough, like.
Tầm 11 giờ em gọi lại nha. Bật FI là lên FI hay là bật thiết bị rồi có FI. Ừ.
Maybe it didn't trigger. Oh. Maybe I need to run it for somewhere.
Thôi để tầm 11 giờ gọi lại cho. Rồi gom lại rồi giải quyết lúc cũng ok.
MSU still wrong place. Yeah, okay, so it is. I think these are, let me see what is over limit for this. The over limit is quite high. So although I sent a lot of power here, 200 ampere or something, and yeah, so it is a bit, yeah, I mean, I need to just make a data problem here. The results are close enough, so I cannot like show that. But I think you got the idea. So right, so you got the idea. Like if something is wrong, it just shows the maybe what I do. I just instead of, for example, this one, I say right 50%. No results. I need to check why. Okay, so I expected to give some kind of find some problem with this. Yeah, so like, yeah, so okay. Locate. I just unselect this. You see here, okay, so in the report is the previous report. These are previous reports. Okay, so this is the message from that load flow. So the overloaded branch is 900. Actual load is 240.
It's about 20%.
Yeah, but that's why, because it was very high, and it looks at the rating. It doesn't even look at the overload, the overridden value. It looks at actual. Yeah, so this is below that 20%. So this network is too good.
What is it?
Sorry, yeah, you want to see that? Sorry. I'll show you. Okay.
What is this index? Bank configuration. What is this?
Bank configuration means like you have on each side of transformer, right? You have for transformer you have banks, right? Which means like for voltage for one like sub HPMB is generally could be one bank. For three-phase one, it could be more than one. Like it could be three-phase, three separate banks. So for those kind of like situation, it will check that like to see if they're correctly defined and correctly connected. So these are for specific networks that we have. Like for example, I don't know, you heard that in the voltage regulator they have like open delta or things like that. So in primary side maybe is a delta, and secondary side is open delta. So it checks those kind of.
So it check like the transformer because we just like it's just a simple model on the system. So how could they know the things change or something wrong with this transformer and check as to
If during when you draw it, you set up this bank configuration and it's there. So it's not going to change during using the system unless somebody goes and change the model. So it checks for like basically modeling issue that we have there. Yeah. So let me see if we can have that. Appropriate phase shift and stuff like that, voltage index. So in normal transformers like the one that we have, maybe I just go to the DM network builder. I have too many. Okay, sorry.
Yeah.
All right, so let me just go to share this stuff. Let me see if I have example of like different types of connections. Normally the one in the substation, they have just like all of them in the same bank, but like in some cases, I don't know about this model. I need to see where we have like different types, but we can, do you know, like we have voltage regulator, which part of this?
For this situation.
In general, for customers we have, like I know where their customers they have, well, the regulator they call it. Okay, let's first go to the normal one and then. So this is like in our symbology. So this is substation, and we then create transformer, and this is transformer area. Sorry, that was transformer area, and this is transformer like in one block. And this is the tap changers and stuff like that. In some cases, we can have like a transformer bank. So I need to find an example in this network. So I Not sure which one has like a, is call it regulator, what do you call it? Let me see if I can find one example.
Thank you.
No, like I mean like the transformers that we have.
Just try and find what kind of
I'm not sure where we have it here. I will try to find it during the break, so and show it to you. But like in here, maybe I paint something just everybody sees. Okay, so some cases you have a voltage. In Australia, we have this one, right? It goes like this, then you have a winding between this and a winding between this. And like, let's say, 3-phase, okay? So you have, these are primary side. So they are like a delta. So in also we can show it like, okay, and sorry. No, okay, my bad. Let me undo this one. This 3-phase, okay, so these are between this and this. And there is one, for example, let's say this continues. And between these two, so this is kind of a delta on primary side. In secondary side, it might be just 2 windings. One with this, okay, so. And one with this. So there are 2 windings and like, they call it open delta. Yeah, so this one, and for this one, we need to create banks to model this. I don't know if you have this open delta or kind of different regulator. Let me Google.
Là cái gì để làm gì?
Maybe
Không á, trong bảo vệ thôi, thì nó nằm ở trong cái VT thôi, cái VT thôi, chứ không chạy có cái gì đâu.
Nhưng mà nó đang mô hình máy biến thế mà để cấp điện.
Việt Nam nó xài cho nên trên cái tàu chẳng nó làm cũng là gì lên. Còn có cái trong vẽ cái bảo vệ có
yeah, this is both sides is open delta, but sometimes you have like this. This is primary connection, this is secondary connection. Sometimes they have this kind of like non-conventional configuration. I don't know if you guys have this one.
So, but it's the understand because you mentioned about some kind of the transformer that exists in the grid, and your system can model this transformer and check something for this model.
Yeah.
Right?
Check that connection are corrected or not. So yeah, these are normal, right? This is normal normal delta, but like that open delta, it's kind of like, yeah, different versions we have. So we support some of them, not everything, like yeah. But generally open data is like this. It's kind of like makes it unbalanced, but it's less costly sometimes because you have 2 only banks. one bank for this, one bank for this, not three banks. So I will find like I see if I can find something in the model and show you. This kind of things they using it when in rural area the transformer is too long. They don't want to send three. Like yeah, they want to save money. So I think. So yeah, this was overload. If you see too many messages and you don't want to see that like overload, okay, you check everything about overload. So what you can say, or I don't want to see overload problems, like doesn't contain overload problems, or you can unselect it as well, overload. So you can put some filters and see if you have covered and everything about overload. So we covered this one before. Yeah, similar to any other applications, we have this. But this is it's a good tool. Is it going to be useful for everything? In some cases, yeah, I would say it would be useful. Maybe for you, you don't need to do this. As you see, if you remember, it was unselected by default. Probably the customers, they don't need that. So, but yeah, I think if you want to see information on the don't want to go to open the document. Sometimes as a user manual, you press F1 and takes you to this and gives you some explanation. See this quickly if you want to see what's going on. Okay, so and that's some part, but I personally, when I do this kind of like checks, I would go to load flow itself and okay, let me just close this one. When you run load flow, and maybe the thing is when you run load flow, it's going to run it for all substation, all feeders connected to that substation. If you get any message here, if there's some problem, like if it diverges or shows something here, it shows some messages here. You need to attend to those ones. So this one, I don't have any problem, so I don't need to worry about this. So I just look at the results of the load flow to see do I find something very wrong. Normally, for example, I check definitely sections loading, transformer loading. Do we have service transformer? At the beginning, maybe you don't have data about service transformer. So service transformer is MV to LV. Okay, if you don't have good information about them, and also they might have tap changers. Some of our customers, they don't have the right data about the tap changers because each one is like somewhere like you get many of these, right? So you have, I don't know how many you have, like 15, 20,000, 30,000, 100,000. So it's hard for them to get the data. So what you could do if you don't have the data, so like you could go to the load flow profile and then exclude this service transformer. So I had already I was playing with this yesterday. I had excluded this. So if you can include or exclude, so if you are happy with that, so you can just include it and run it again. So here you see normally because if what happens, like you have one load under this, the load is incorrect and it checks it against this nominal value. And if it's against nominal value, it complains about, okay, that doesn't make sense. Too much load under this, and it flags it as a potential problem. So I just, for this one, for example, if I turn on this, Let me see when it can run this. This I think substations are very good, so it doesn't complain. But I normally get when I do tuning, I get like problem here because the load was incorrect, and then this one it probably need to turn on S. It's 25 kVA. In our customer sometimes it's 100 kVA, and then you go here. And rated power, this one is 100, doesn't complain. But if it like was the other way around, this was 100 and this was 25, it would have flagged it as a problem. And yeah, so this one, it depends like if you include it or not. Then the voltage, if you is the last. So I check first for sections, transformer. If this one is included, I consider this. If you have switch devices, if you have information about the rated power of them, you can also check. But this is maybe useful if you want to do, I don't know, freezer or some stuff like that. For your case, probably switching devices, maybe you don't need the rating. So that is fine. If I want to do like, okay, the other tool I use is the load profile itself. The load profile, you can actually select any part of the network that you want. Let's say here, all right. So I right click here and say I want to know the load profile. Is this load profile like this is forecast, but you need to look at the schedule. So you can check, okay, does it make sense to at this point of the network I have this much load and you have P and Q. Normally when you have measurements, you can go and check that area, like I don't know where we have measurements here in the feeder. So I normally check there to see if they are kind of like close enough or too far. Okay. So that's load profile. And yeah, if you want to check the voltage, probably you want to use the voltage profile. But this is probably for your case, maybe. Yeah, it's going to be next stage, so you can see. And here, one thing about this voltage profile, I show you here. So this is calculated. This is measured. So the dots here are measured. The lines are calculated. So let me just remove these ones. Oh, it also, yeah, it shows both of them. Okay.
So this is the voltage profile for the feeder, and this is the beginning of the feeder, and this is the end of the feeder.
That's correct. Yeah, that's okay. I think
So
these are
you like have the measure from the on of the point in the feeder.
yeah. So these are three phase. Okay, their coloring is like phase 1, phase 2, phase 3, red, yellow.
Yes.
So that's three phase. And then here, for example, it says there's a capacitor here, right? You see the capacitor element, locate. And this is your, why we put here, because it impacts voltage. If you have turning on this one, your voltage would go up, right? It might depends on the Q, yeah. So we can check that. So Q, yeah, probably. Okay, so if I, for example, close this. And let it run. Okay, so it used something, and I refresh this one. You see, moved all the voltage up.
Yes, but I mean, where's the measure point come from? Like in your feeder, I don't see you.
Oh, sorry.
The SCADA device can measure those for you. Is a lot, like 50 points, right?
Sorry, I think I was wrong on this one. I think this one is just yeah, the measurements here are not there. So because you see, if I remove these, I was just trying to see where they are. So we don't have measurements actually here on this one. Maybe I have it under somewhere else. Let me just find another one. So this one is secondary side of this, I think. Yeah, so this one, if I go, why we have this? Because this one has voltage drop, right? So primary and secondary are internal view. If I have the properties, so it's a voltage drop for that one. If you have a tap, you can just change the tap and see the impact on the secondary side. So these one are the nodes of transformer, you see. You see primary side, if I make it per unit, is 123. Secondary side is 121. It's the voltage drop for this. For transformer, yeah. So 121 is kind of like here. And this dot shows the secondary side. And primary side is actually here. You see 123, and it's kind of there. If you hover on it, it just tells you which one it is.
Cái này mà mình đâu có
Anh giám đốc được anh, được anh giảm, nhưng mà phải chạy ra hiện trường gạt cần á, mà thường nó chỉnh cố định là nó gạt nó nổi đâu nhiều lắm, 50.000 cái đi gạt xỉu.
So if you hover on this, you see it says 121.90 and 129.90 is the secondary side. So that dot is representing the secondary side of these transformers, right? Yeah, that line is MV line. Let me just find somewhere else. Like, okay, so I close this one. Let me just do it for, I don't know, in here we have very more.
cái tôn được phát hay là có bỏ vô nhiều
Cái dũi xong rồi nó tự tinh chỉnh lại cho đẹp. Không, nó dũi, nghĩa là đẩy tiếp vô là cái chính, xong nó dũi ra rồi, ví dụ như anh thấy là nó sắp xếp chưa đẹp thì nó có thể kéo lại cho đẹp, vậy thôi à. Vấn đề là cái gift của mình xài được hay không, hướng dẫn hỏi.
Yeah, this one, yeah, we have some measurements. So, yeah, so I'm doing from this transformer. So it has 3 figures, right? So, and then if I go voltage profile, yeah, it goes like this way because it is 3 different feeders. That's why it shows it like this. But let's focus, for example, on like, I remove the calculated from load flow and state estimation. So these are the measurement. They show also as dots. So if I go here, yeah, okay. So what I sometimes also do, maybe when you play with the system, you would like to have, so it's measured value. You want to see the analog. So contains. You want to see the measured value. I can call it measure. And I kind of like star it so that next time I come here, I just press that button. And okay, measurement type, relative voltage. So yeah, so this is 125. Yeah, yellow one is basically, what was the yellow one? L2. Yeah, so this is B2, you see, A, B, C. So if you, okay, sorry, just go to properties. You see it's phase L2, so that's why it's yellow here. And okay, this is a little bit, if you run a voltage profile for transformer, you might see this kind because yeah, they're for kind of like different elements, but they go on top of each other. They're same distance to the, it's probably you would run voltage profile like for one of them. All right. So yeah, you remember when we were doing model readiness, like it was complaining for voltage. So the voltage is like not quite within the range. So you voltage, if it's too far from each other, it doesn't seem to be good, or maybe your network is like that. We don't know. It's unlikely. Okay. All right. So this is I just give you some more about, okay, load flow. This is load flow. So I just go for a state estimation because the state estimation is an interesting one. Now let's see. I run the state estimation. So firstly, it says questionable, means like not everything is all right. Okay, so here you get this message, but to actually see what's going on, you need to open the report. Okay. So this is not quite happy. You see a lot of yellow here. Probably individual doesn't have much information, just give some statistics. I look at these measurements next. Okay, so if there are too many columns here, but like you see, it is questionable, okay, for one reason. So that's why everything is questionable. The next thing I probably kind of like quickly check is it says, discarded, not correct. Why? Okay. Let's focus on where, when I start tuning, I look at megawatts. I forget about kVAR because kVAR is noisy. So I make like my filter measurement is active power. Active power. Active power. All right, so active power, I have only 4 here. So this is the same place. This is the total, and this is ABC. Okay. So this one is, let's see where it is. Locate. It's actually the total load, right? It says 14 megawatts.
So the expected value is come from the power flow.
Load flow, exactly. So when
estimated
value is like output of a state estimation with some algorithm that it applies to it. So what happened here? So you have a load flow results from load profiles, right? Without any kind of impact of measurements. You expect that measured value would be in a similar range. I was explaining, I think, I'm not sure if you were here, I think probably, maybe not here. So we have a maximum allowed estimated to pre-estimated value. So if they are too far from each other, it says probably something wrong. Maybe their load profile is wrong, or the measurement is wrong, or topology is wrong. So if it's out of those limit, it says, okay, I'm not going to use this measurement value, discard it. The second thing it will use is these parameters, this first two parameters, absolute measured minus expected, measured minus load flow. That's for current, okay, it's 330 ampere. And this is based on 20 kV voltage level. If your network is MV is 20 kV, you don't need to do anything. So you can use this directly. And that's for current, but for IPQ, for P and Q and I, so also it uses percent. So if this is more than 30% of this, it also says, oh, it is kind of like, maybe it's not correct. So I don't use it. That's why this happens for this, because I was like actually doing some stuff in the background when I was kind of like in the network simulator. I put load scaling to 400. Like, yeah, in reality, you don't have that kind of situation. Okay, so I deliberately wanted to show something wrong, but let's put it back. Let's put it to something reasonable, like let's say 110%, for example. When I put 110%, so the Montana Sky, I am looking at this feeder MS04. So yeah, the value in load flow updated, and that would be reflected to here. Yeah, so you see that was 12 megawatt something, and then sorry, 14 megawatt, and then I need to run state estimation and refresh these results. So now, okay, so I go from overview. I was very happy. So why? Because now this 4.3, the calculated from this is this, and so this two minimum and maximum comes from this expected value, and the value we put in this state estimation, basically discrepancy. So 30% plus, 30% minus of that. Yeah, so basically when we say, okay, estimated is like this, minus 30% plus 30%. If the measurement is between this size, it says, okay, yeah, because it shouldn't perfectly matches the load profile, right? So it is within that range. And then it marks it as correct. Okay. So in the beginning, so 30% is like default. Like you could, when you're not quite sure, maybe you maybe increase at the beginning, maybe make it 50 and find bigger issue, and then when you can decrease it to 30% when you fix those big issues. All right. So that's one thing. Let's say, I mean, I remove the filter and I see everything else is good, but I could have looked at different ones. So I show some another kind of thing here. So I don't change the load scaling, because when you change load scaling, everything changes beautifully. So what I do, I say, okay, let me stop changing this periodic everything. So I don't want it, this automatically runs. All right. So just I select for now. Maybe I better do even like I just inhibit trigger from here, just make sure nothing is going to be updated. So one was enough, but okay. Let's say your measurements is you have a transducer problem. It's just fluctuating, and so it's not quite correct. So instead of 4.3, so like you got 0.3, right? Wrong value, right? It could happen in your network, right? So when I make this manually 3 in network simulator, here H was 0.3, all right? So the ampere didn't change because I didn't run dot flood. Now I run a state estimation. Then I refresh this. Okay, so something you can notice here. All other measurements like that I have, they look good except this one. What is this one? So you can see, oh, it's the one actually I was manipulating. So the measured voltage is like 300, and then expected is like this. So it's not like close to each other. So it says discarded, but when it's discarded means it uses all other information to make a good calculation of this. So this estimated value is from, for example, okay, I have current, right? Because current kind of like can use that. Kilowatt can use that. So the algorithm tries to find all other things, and that's the one of the good basically main use of a state estimation. If because you don't see this, right? So in your network, like many of these sensors can go wrong. A state estimation runs in the background. You still get some good results, and then from time to time you need to come and look at this report to see what is wrong. So normally what I do, I make some quick filter here to find the problem. I mark it as equality is not good, okay? Isn't good. And I make it maybe quality not good, okay? And maybe I make it global. Like if I go, let's say, expand all, let's say I want to just from time to time, I want to see what is the problem. So here it shows, okay, unknown as well. So maybe I don't care about unknowns because maybe they are not connected or not something else. So I can create another filter. And maybe I create this one to not good, not yeah, kind of like this. And then you can easily find out what are the problems in your network. So like, for example, is this one, let's see, I just found this one. It says SCADA quality is good. Measured value is 0. Expected value is 0 out of calculated limits. So it is, yeah, it's noisy, I guess. Yeah. Yeah, I think you got the idea, like, right? So you got the idea what to do, and it's kind of like you need to find the best filter that when you do tuning. I think you can use the other filters here as the other columns here. Delta between measured and expected, delta between measured and estimated. So you can use this. What I do also, I sort based on this percentage. Okay, so I want to know what is the worst case here, and like reactive power is normally not really good results, so that's why I usually remove it. But you see the worst case actually per percentage is like this. Per absolute, this is absolute value. Actually, my kilowatt is the worst. So maybe you need to play with these two numbers to find out like other problems, right? So. And what you do, let's say, you see automatically when it's trust factor, this is finds the problem, it just puts trust factor 0. You could also go and, okay, control value, you know, this is wrong and for a long time is wrong. So you go here and say, okay, don't use it at all from the beginning. Don't even look at it. So you can say not used in ADMS. Yeah, this is for trust factor. You see, trust factor default is 80, and then you can move it. Okay.
So what do you mean, like pick the don't use option? Is the element system we use the estimate value or the expected value?
Estimate, but if you mean if you mean other functions, like let's say forecast, everything else, like it would use the estimated value, even if it's wrong, like measured value is wrong, right? It still would use this estimated value for its own purposes. So, and you can actually put it on the curve as well. So when you say add trend, it's another way I check as well, because you want to see this sometimes over the time. So, okay. So you see this one. Because maybe we are not like saving it. Okay. All right. So it doesn't show the last one because maybe we are not saving that one. I think I need to check. Maybe we save this one. Okay, go there. Let's see. You go here, add trend. And historical. Okay, so firstly you get the signal. Too many signals here. Megawatt, okay. And then you want to see load flow. You want to see P, okay, total. This total P, okay, or I don't know, like this one. Okay, the total P I think should do. And then let me see. Okay. Yeah, maybe we don't show that this. Okay, I need to check. There is like some configuration tell the system what to save, like in historical. Historical. Yeah, the first one, historical configuration. So here you can tell what type of things you consider in the store in the historical. Like for example, analog signal. We say, all right, get every hour, average, count, blah blah. So we have for analog value, and then for load flow and state estimation, you can find like what device, let's say load breaker or circuit breaker. Yeah, and then you can choose. That's why it's not selected here. Like load breaker, I think we got circuit breaker too somewhere. Yeah, circuit breaker. You could choose this. You can say, I want to collect this. I want it every year. Like for example, is that one, right? And then P total. Okay, so P total. Yeah, you want to do this. Okay. Want a minimum snapshots. Okay, whatever you want to do, and you need to save it. And when you save it, it restores in the system. Yeah. Because we don't select everything. Because you see, for just one transformer, how many data we have. And if you think of like this, for all elements, it's going to be too many. So yeah, we suggest only put like for important devices like circuit breaker, for example, and like for exactly what we want, right? All right, so that's why it doesn't show, but like, yeah, I think maybe it's good then you start using the system. If you use a state estimation, select some of these things. Yeah, and if they are like over the time, if they were selected before, you can compare them together and see, all right, it was good at this time, it was not good at this time. The other also in this state estimation report, we have a statistics, so you can run for different times and see some details like, okay, so this one, for example, how many times were good, how many times were bad. So it just shows the good and bad. It doesn't show the value, right? A state estimation questionable, a state estimation bad for that period. If I, for example, go 1 day back, the value is better because 98%. Because this morning I was changed it like, right? So, and then we had a lot of like questionable. But if you compare like for 2 days, most of the time was correct, but like 1% of the time like was not correct. And I think you can just sort what is the worst case. Or create filter. Okay, this is, I think, tuning. One thing I think I would say, I just give you one example of what could go wrong if you don't have the switching right. So let's say I go back to this configuration. Let me just put what I were disabled, and then let's say let's select all of this that I unselected. So it runs in 15 minutes, but let me just push the load work. This one is this 3. Let's see if it goes back to right. So, oh, okay. So it took time. So 4.3. So now imagine like here. Is colored by feeder, right? So this was our MS0. Where is the MS05? Sorry, just maybe it's not the right one. But this is the yellow one. Okay. Let's say this is a manual switch, right? You opened it in the field, somebody opened it. Okay. And then you close this one. The network is energized. This one you see in the ADMS, right? Because it comes with a SCADA, the telemetry one. But this one doesn't come automatically. Somebody needs to go and change it, right? So if I go to my, I see energization. Maybe that was telemetry. Okay, just let me see. Which one I selected? Telemetry. No, it's not telemetry. Okay, so let me just get the custom ID of this. Okay, it is shows close here, but there is open. I think maybe the other one that I was changing as well. Maybe it was manual. Okay, so that's not okay. Maybe this was also manual. Okay, so let me just see here. It's a bit kind of like, yeah, this was also manual. So both of them, let's say manual. You change the network in reality, but in the real time, you see the coloring for this is kind of like two different colors. Here, if you go here and I change the coloring, so it's the same color because it thinks it's normal, which is not in normal. So what happens? So your megawatts changed because in reality, you shift the load from this feeder to another feeder, and in reality, your load is lower, right? Your load is much lower. Now, if in real time you just run a state estimation, which can run every 15 minutes anyway. So, but I'm just a state estimation. Okay, I got to here. So that thing marks questionable. Why? Because of like, okay, this is megawatt based on the topology, we think is 1.3, sorry, 1.3 based on topology versus the measured value is 444.
Is there some way to check the topology of the requirement?
Yeah, so you need to kind of like, okay, so this is the total, right? The total one that we were working for is 99940. So how you check topology? No, if somebody doesn't tell you I changed the switches, so you need to check the manual switching also, right? So that's the impact of topology, the first thing we said, okay?
Basically, when we have like many questionable like this, maybe it has the wrong topology for the grid, so we have to check phone, either to check high device, is it correct or not?
Yeah, so I would say if in your system, how does it work? If somebody goes like in the field and change a manual point, how do they inform you?
Yeah, they have to like make a phone call because before they switching the devices in the site, they have to we have to confirm them that they can do it. We allow it. We allow them to can do it, and they have some like order, and they check the state of those devices, and after that they make a phone call to us and yeah say that, oh, okay, we just opened the switch and could you update the status in the system. Yeah, but sometimes they forgot, maybe, or we received the phone call and we forgot to update the status in the system. So that's happened sometimes.
Yeah, that's
good to check
one.
the topology. Yeah.
So you need to change what's saying in our system. Sometimes whatever you manually change in your network, you can also send us to you need to change in both systems. Or you can, I don't know, maybe you can. Serena, can we get manual switches like through ICCP?
For ICCP manual,
Yeah.
but if ICCP it will be remote.
Hmm?
ICCP, but they have manual switch, but they will send to us via ICCP.
Can we do that?
Yeah, if they can create and there, it's okay, fine for us.
We need to create like remote point in our
Yeah,
phone.
for our side, it will be remote point, but they have to, if they can.
You know what happens, like,
Yeah,
in our system,
in our a lot of points.
Yeah, we don't want to
do
Yeah,
for the ICTP, so I don't think so for this project. I don't think.
Yeah, but I'm saying, yeah, it could happen in reality, but like, yeah, even not like that, your fuse is blown up, right? So your fuse is blown up, so, and then somebody needs to go and find where the fuse is and just call you, and then you update in your network model. So this is a little bit, that's why state estimation is a little bit needs time to fix everything, and yeah, so that's why you wanted to also go to maybe a SCADA base. But that's kind of like my kind of like explanation about tuning processes.
Okay.
All right. I think I can switch to the next. If you have any questions about this, so if no, okay. If you give us like some this data to us, we try to use LPG to load it into the system, or you could just send like a curve, like if you have already, like for each feeder maybe, or like for all of you, or so I would say maybe we start with just one curve, like you say, okay, our residential and everything is like this, without using this data, because you need to get the data to fit to this one. So I don't know if you have it.
Let me check.
Okay, if you don't have, just give some from your SCADA. I would say you look at the whole substation. Like you have one substation, you just get like a typical load for the weekdays and weekends. So simple as that. We can just put it there to start with. All right, so the next topic is forecast. Do you okay? No break, no nothing. We can go ahead. Yeah. Okay, forecast is to provide the expected system load and generation in future based on historical measurements and forecasted weather data. Okay. The forecast results will be used by other applications. Some, not all of them, of course. So some of them we can use. NTLF, near-term load forecast, is normally 24 hours, and it shows like hourly intervals. Short terms, 8 days, we can actually configure this to make it to different value. Maybe we can make it to 14 days, but normally, okay, 8 days is good enough. More than 1 week. Medium term is not using weather forecast. It's just using some kind of like heuristic method, and basically maybe it's like rely a lot on the daily profile and stuff like that. And for the project like DERMS and power applications, I haven't seen anybody really uses this. This is more for planning. You have some OMS system and switching management system. You have like in 2 weeks, let's say in 2 months, sorry, you have some work. You want to see what would happen in that time. And if the customer like yourself, the measure doesn't change that much, probably you don't need that. So I would say we need to focus on the first two. The long-term planning is not, again, I think it's out of scope even for this one. It's for planning department. It's not for a SCADA department. So it says, okay, what would happen in 1 to 15 years? But I put it into my presentation as well. But like, okay, so what is the data requirement? NTLF and STLF are basically kind of common data is used for both. We can use measured or estimated. If we use measured, we need active and reactive power. Estimated is using, like I was showing to you in this historical configuration browser, but it is actually on the feeder. So this one on the feeder, I need to, is a very specific information we need there. So for feeder, we need this P consumption SDP and Q if you want to do Q as well. So this one is the attribute that we're after. Is normally hidden from like the display. We can show it, but like it's only used by applications, and we just use hourly, right? So but also we selected the month and year just to have full. You need to have integral and average, and we use the average actually. So yeah, but average integral is necessary for average. So this was estimated value. Weather, we said, okay, do we need all type of weather? It depends on the customer. So it's for you, maybe temperature is good and humidity is good and insulation. Some customers, humidity maybe is not quite impactful. We don't use. They have another quantity called feels like. Feels like is combination of like everything. Like how do you feel? But is it good to use? Depends on the customer. You know, does it impact your load? You need to think of, okay, does it impact, which one is more impactful to my load? Data, we already configured this. Prediction, I think we said, okay. Annual schedule. What is a schedule? Means like you have some generators on the system. They have some array signal and they can get that forecast either from another system or is already, and you can define it yourself. I think we were showing how manually you can update that data another system, but yeah. How many days we need? It's about 90 days. There is 2 algorithms. For that algorithm, this is similar day. So the similar day, it needs 1 year. Why? It looks at last year. Like, for example, right now is, I don't know, 19th of March. It looks at like last year, the similar time. And around that time, it's not just as simple as just the last day, 19th of March, but it looks at if it's weekend and Thursday, Monday, like look at the day of the week and stuff like that, and do some averaging. The other one that we don't use is like a machine learning tool, and it just use the machine learning for training and prediction. So MTLF, I passed this one because you're not going to use it. LTLF as well, you're not going to use it, but just for your information, this is only for substation level, not to the feeders, which is, that's probably is not going to be useful for you. All right. I think we already discussed about this, state estimation, if not exist, a measurement, okay? And this data also used by state estimation, like, right? So if you want a state estimation, what is the profile look like? Maybe I show this on the system, it might be easier to understand. I just briefly, we go to the our library, and we have everything. You can go whatever you want. The start time and will be different. Why do we have put start times is different? Because machine learning is CPU consuming. If you have a huge network and it's in the scope, it might take, I don't know, 1 hour to do training or 30 minutes to do training. So you want this to be a bit different, or you want to run it on the time of the system that is quiet. Like during the day, a lot of loads on the system, you send through. Like we have, like, for example, one customer that they use all the applications of ADMS, this field crew, like people connected to the system, we put it at night. Yeah. And it does training, and then it starts prediction. Prediction is normally faster, so it takes like a few minutes, like 10 minutes for the customer that we have. It was taking about 10 minutes, maybe more for somebody else, maybe less for the others. Okay, so this is made up here. Similar day. This is again the decision interval 7 days. Why? Because it's a week, so you can look at a few days around that time. So let's say I'm just want to make some averaging basically. These are like significant temperature change. I compare apple with apple. Like, probably you could change this to lower value. If the temperature range is the same, it looks for the time of the year that is the temperature is close to each other. So how many years we look at? Like if you look 3 years, if you have 3 years information, we have 3 years, we can put up minimum 1 year. But okay, I normally in the other project we don't use this similar dates, so we probably will see for you probably the middle the machine learning is better. So this one is applies forecast error to results. So like it can kind of like guess the error and just adds it to the results. Here you can select estimated or measured. So this one, for example, is the state estimation model update. If somebody models the update, change the let's say add a new substation or feeder, it will trigger it and that signal update as well. So the other ones, okay, normal. Let me just connect to the system because one thing I have problem here is if I don't connect to the system, it disconnects and it takes a while to connect. So I go to this one. So let me just close this. Okay, I explain all of this. Here, all right, so this was I was showing measured or estimate value. So estimated value currently selected. Yeah, if the model is updated, if the signals is updated, it triggers it. So what is this normal circuit deadband? I was running the system in normal. I did the shuffling, right? So I did transfer some load to another one. So the circuit is not normal anymore, right? But the forecast results, let's say when it's normal, for example, in our case, it was about 4 megawatts, right? So it's, for example, it fluctuates between 3 megawatts to 4 megawatts, depends on the time of the day. But if you have abnormal, like I did, it just dropped dramatically to 1. So if you want to use forecast over the time, it might impact the results because, okay, what is the normal? So there is like a deadband if it's more than it uses the normal network. If it's less than 20% difference compared to the normal, it doesn't use it anymore. You know what I mean? Like because in our case,
understand, but what's the exactly value they call normal? Because when we run on the time the log we change, right? For your example, the log we change from 3 megawatt maybe go up to the 4 megawatt. So what is the value of the normal?
it based on the like the training it has. Like let's say you train this and it was normal, and then it has a range for that. So it has a range for that, and I think it also looks at the time of the day. So it's in its memory, like it has like a curve, like the one that I was showing in the.
Or maybe it would check like maximum value of the curve and minimum of the curve and multiply with the percentage you accept that. And
Yeah, so it's like when it runs in the background, it has like a kind of this input. Let's say this is the input, and it kind of like concludes is like this. Now you are like
lower.
Yeah, your voltage is 20% high and low. It still assumes it's normal, but like if it's at this point of the point is like here, it's more than 20%, then it's not normal. I'm not going to use it for my training or something like that. Okay, so this one is like if the temperature changes like the dramatically, like more than this percent, it will trigger to run the forecast again. Because let's say you have forecasted the temperature would be 30 degrees, right? And then we have forecast and it shows there. Now the new forecast says, okay, at this time it's going to be not 30, it's going to be 38. So if it's more than this 5%, it triggers to run the prediction again. So this is kind of like to mitigate like small like because it runs every 1 hour, right? So if we run every hour, if within 1 hour, it's or maybe you could change, for example, here to 4 hours. Like you don't want to run it that often, maybe because of the CPU load, for example. You're restricted to CPU load. If between these 4 hours, change something, you will the measurement is changed significantly, it reruns and puts the right results. And we have different percentage for different, basically, quantities. Maybe we need to check with you probably what is the important one. I think wind, if you don't have like wind farm, maybe this is not like we can put it really large value because no matter you have wind solar in your system or not, if the weather changes more than this, it triggers the calculation. But I think we don't need to be very worried about yours because your model would be small at the start, right? So if you make a huge model, then these values you need to revisit and change them to avoid too much CPU load. Okay. This is like a new alarm, so you can have an alarm if the forecast error is a lot. So this is basically from like configuration of point of view. So forecast is like this. The input we explained. We have a tool in the background to load the data. For the start, we kind of like do we have that document? Let me see if I have it open. I was sending to you, I think, the other day. Let me just stop sharing for a second. I find that document. Is this one, right?
Okay, yeah, ตรงนี้ค่ะ yes. In page 4, import something.
Yeah.
Yeah, this one.
So we're gonna do this import like for you at the beginning, but like in future, if you want to update the data yourself, you can use it. But to be honest, it needs only at the start of the project because as the project goes, the historical data is already stored, so it's going to use the previous data. But let's say you want to use it under, let's say, future when you want to put the system to production. There is a tool, we call it Forecast Historical Data Importer Tool, FHDI. And then, so the input to that one is some data like this. For example, you need just timestamp, unit, and value, and these are for a feeder, megawatt and megawatt. Okay, you create this file and you put it the name as like name of the feeder, and you can have multiple of this one, right? So you can create feeder 1, feeder 2, feeder 3. So each of them is in one file. And then you create another file with a list of the files. So similar to this. So this is the second file you create. So basically it's placeholder to reference which file is what file. So this is the name of the file and it's the name of feeder. Okay. And then this is for a load. Then you use similar thing for weather. So for weather, for example, you put units as in this table. You put, for example, watt per meter square for irradiation. You put Celsius for temperature, right? And you create a file for your solar as well. Like, sorry, weather information. It could be solar, blah, blah. But you need also name of, I think, weather region, right? So weather region.
So similarly, I use the tool to import the data, right?
Yeah. So me and Serena, both of us work together to put the data that you see there. So yeah, use your data. So okay, so yeah, we put it in the tool, and then what happens? It goes to the database, and then when we I probably close things that I don't need here. I think the next one is just show the results, right? So in my presentation, and I'll see what I have. So yeah, so it's showing the results. Let's see the results. Okay, this is kind of like the whole system. Maybe it's a bit, the problem with this one is if one item isn't wrong, it might show like wrong. So this to me is wrong. But okay, let's say Montana is Texas, let's say. The one that we know that we put data, because we didn't put data for everything. We put for some substations, right? Did I put it for here? Oh, it was maybe not for this one. Okay, this one is good. So MS04, for example. All right, it shows P and Q. I think briefly I showed this one before. Consumption is green one. We have a situation that this one maybe it's just better to see. So the consumption is the green one. Injection, consumption minus all of these other productions is this orange color. You see it says production here, but production could be, okay, solar, basically. It's basically, they're on top of each other. That means we don't have anything but solar here, and renewables is the same. So, and where this comes from? I'm sorry, just explain about that extreme points again before. So this is a forecast that Owana put on the system. So the temperature I think maybe she ran it any wrong time. It's like showing the high temperature probably at night. It should show that during the day. So maybe when she was doing it, it happened like that. But maybe, yeah. So based on this data, so if that's another example. If your data is wrong, your results are wrong. So this irradiation, it says okay, up here is maximum. So this shape, if you think here, it would impact the solar, right? You have mid sun at midnight, I guess. Maybe you can. Yeah, so I think yeah, it should we can fix it. I was asking her to fix it, but I think she finished her work yesterday.
The timestamp or
Yeah, sometimes that maybe she put UTC versus local. I don't know. And we can fix it. Yeah, at the beginning was correct. So a few days ago I was correct, but we will fix it and show it to you. Yeah. So this is like, yeah. And the temperature and blah, blah, it impacts this. And this one you could see, for example, 3 days here. You can say, all right, I want to show 7 days. Right. And I don't know how many days we have. Yeah, we have up to 8 days because the default was 8 days and we are just doing 8 days. So the other information you could get here is like, okay, extreme points. So extreme points for peak consumptions, it says, yeah, 4 a.m. Okay, so I think probably 4 a.m. is not highest, your highest maximum. Oh, I'm sorry, it's minimum. It's actually not bad. So minimum here. So my bad. So maximum time is 5 p.m. here. So maybe consumption is correct, but production is, I think, is incorrect. So yeah, this one looks at these curves and shows this one. This is another presentation for average and things like this. I personally didn't use this one much, so it shows a bar chart at like periods, you know. Yeah, you can average monthly, you can average daily. So it's kind of a, like gives you some hints about what could happen, like in intervals, like per intervals. The other thing you could do, you can actually go here and see the in tabular. Tabular also you can export this, right?
So we can also like query those data from the historical server.
You can, sorry?
Query those data from historical server. I think
Carry, yeah.
maybe.
Carry, you mean, I don't understand. When you say carry, like
Query, I'm sorry, query, SQL query.
query,
Query,
query, yeah. Yeah, we can, yeah. For testing, yeah, we can. All right, so I show you there, but this is like export, like results. So it's a CSV file. You can move it to Excel file, and it basically shows what you have here. So if you want to analyze like further, what is the forecast, what is the story? In history here is this one. So it's this current time. So this is the back historical time. Yeah, in this one, it shows it here. Yeah, so I think also what else you can do here. Right. You could edit this as well if you wish, but I don't think anybody would edit the forecast. But you can say this forecast is wrong. I want to put this value, but like you need to put a lot of values everywhere. So you have that option, but The other thing I would say, you can just to like play with manually. You can also run forecast. Like for example, you can drag and drop here and select the algorithm. So this support vector machine is like the one that I said is like machine learning kind of things. And then if you can say similar day, like this is the one like looks at the similar days, less sophisticated. You can check both of them and see. Maybe in this one it doesn't work because probably we don't have 1 year of data. I think it doesn't work. So most of our customers use the other one. So I think this one doesn't work. Okay, so let's do this again. You can feel how long it takes. This is for one feeder. Yeah. So maybe, yeah, so this is the results of that. There's the display is same, so it's similar, so you can, yeah. Okay. This is just like at the start, you want to just, I just play with this system, like to see what is different. You want to see the results on the historical results or input data. I know input data. I need to check where is the query for out data. In the specification, there's some kind of like explanation of like the codes we're gonna use. So this is the import tool that I was explaining to you. Okay, so let me see if I have something ready-made here. So yeah. Yeah, so let me put like, I don't know. Yeah, I don't have analog measurement because yeah, this is kind of a query. I just want to find someone that. So this is the data we put in for you, for example, for weather. For weathers. No, this is the input data. It's in, like historical, yeah. So historical, like this is table LF S AGG hour. AGG means aggregated hour, like every hour. LFS load forecast service. And then you need to, in our system, we have something called GID. Okay, GID is an attribute like a unique attribute for elements, for all elements, we can put it there. So let me just show you what this one is. It's a weird number, but okay. Oh, now we cannot, maybe that is,
Oh,
yeah, no, maybe that one is, I missed
this
something.
is JD forward.
Let me see. Let me take the other one. Maybe I am wrong.
On your file JD in.
Hmm?
Maybe you can try to find JD in Google.
Yeah, so okay,
It's
so
easier.
easy. Okay, I go the other way around. Maybe I model browser. Yeah, it really is. Yeah, it's there. Okay, sorry, you read it. Yeah. Okay, so this one is, yeah, you get the GID from this element. So yeah, you remember we were talking about, okay, you got the historical model browser, you go to this, but like in this one, we have a lot of signals, which probably we don't need, I guess, for testing or other things that people do. But if is the right one, it's actually this one. I don't know why it doesn't show it there, but okay, maybe I need to change something. So yeah, so you put this one here. And then this code is basically defined in the specification. It's kind of a code, but it's for analog signals like that. So yeah, if we go to the forecast document, I can show you that one too. Do I have forecast open? Yeah, it's in the specifications. Those codes are in the specifications.
No,
The other one,
No,
not this one, the other one. Sorry.
Their code.
Okay, model code. So now I thought that is my how do you write it? Model code.
Oh,
Model code.
this one, I think.
Yeah, so it's actually explained here how does that select works.
Maybe go up, yeah.
Yeah, that value there, it was from here. Yeah, this is the SQL that I was showing. Now, it's not exactly, okay, table, okay, so table could be different things. Table could be one of these few tables. But you got the idea, it's kind of like, yeah. I can share the one that I have, which, it works for you. So this is this number. So that number that you were seeing there is this number. Yeah, this number is the other number. Okay, that was for forecast. Let me see if anything we need to explain more. Yeah, you can basically this one is you can edit the historical data. But I personally don't think you're gonna use this. You can change something, but you can also put some scaling factor. Like change all of the forecast, like. Let's say your data was wrong, you don't want to touch the historical data, something happened, and you can select, for example, I want to change Q or P over this time, I want to, for example, would like multiply it by something. It's kind of big, but like I wouldn't know like when you use it. Let's say forecast was historical data was wrong. You don't want to change the historical data. You want to just change the output.
For what?
Yeah, for other applications, because other applications that uses forecast, you want to change and correct it. Okay. I think pretty much. Okay,
This money is. That's money.
Yeah, I have like more, but we can do it afternoon, or you wanna continue? I don't know, maybe if you're not tired, so we can continue.
No, I think we can continue because it's up to you. I think
Okay.
we will have more time.
All right, so yeah, better to. Yeah, basically kind of like this was from afternoon, but yeah, I think we can go. So yeah, this session is about DERMS look ahead. So yesterday we talked about the application such as ANM and DR monitoring and all of this that basically is real time, right? So DR monitoring is real time, ANM is real time, but look ahead is like looks at forecasted data and tries to sorry, I just stand up for my guys sometimes, and it's sometimes feeling better to explain here. So look ahead, we enable it for the area that we have forecast. We want to see what is the impact of that forecast for our network, right? So what it does, we want to firstly visualize what it would happen for all the information on that network. So if you have load flow running, let's say how a state estimation and what a state estimation works. It uses the current measurement, right, to show the results or quantity output for all elements on the network, right? So assume that now you have forecast instead of like 4 megawatt now in 3 hours, you have 6 megawatt. It uses that 6 megawatt like as an input and tries to run a load flow based on that adjusted value for all the network. So you would see for each interval, if let's say if you run it every 1 hour, for each interval, how would it work? So basically, if we let's say we do it for 24 hours, it runs 24 load flow based on the results from functional forecast. So it's a lot of calculation as well, right? So real time, it only runs once, or state estimation runs once, and we normally calculate schedule it for 15 minutes. For look ahead, the reason we maybe in some cases 1 hour because too much calculation depends on the like system. If you have too much CPU, you can put it every 15 minutes or 30 minutes or something. But It depends on the use case as well. Maybe every 1 hour would be good enough because forecast is not like as accurate, so you don't have, you know what I mean? Like 1 hour is good enough for look at the studies. If you do it faster, maybe.
So we can
get
choose the
much better.
time like for we want to look ahead next 1 hour only for.
Next 24 hour, but in 1 hour interval. So
Yeah.
let's say right now it's 10 o'clock, and let's say we start at the right time. So it runs at 11, 12, 13, up to 24, for up to the next 24 hours. And it shows the curve for internally, actually calculates everything. It shows only violations probably for like critical section, right? And then it can create alarms, right? So it can say your network is fine in 3 hours from now at at like 3 p.m. or 2 p.m. You might find that you might get overloaded. So it kind of gives the operator some kind of like visibility to take action earlier than wait to actually overload, right? Maybe they can just switch the load from one area to the other area, or maybe they can, in this case, like you can say, we turned on or turned off, things like this. So this was kind of monitoring part, right? Monitors and raise alarm, also mitigate the constraints. So for this one, finds a way to mitigate the problem by sending schedules to the DRR. Like remember,
So this while send the flexibility of.
similar to what flexibility that we had, but what flexibility we were more. The difference here is like that one is more for system. Somebody from like transmission network tells you this is your constraint, but in this case, let's say one section of your network on the MV feeder, it feels is overloaded, and you have just a battery just downstream of that, and with that one you can impact and resolve that. That what flexibility, it looks at like higher picture, so like for the whole substation or region and blah, blah, but this one looks at individual elements in your MV network. Okay, so for this constraint management, you can just run it manually or semi-automatically or automatically, right? So it goes and similar to ANM that we showed the other day. So this is kind of base, right? So we can use real-time data and data and topology, similar to ANN, but if you want to have a more accurate actions, probably better to use the state destination and some like you can find violations on more elements that are not telemetry. Currently, we are doing on an MB. In the next version, we are expanding this to LB. Right now, we're just doing the this one, I think you asked this question for ANM as well. So here is the same, right? So instead of totally stop the curtailment, we can say except what we could only make it off or whatever that is needed for us. Similar, this ANM and look ahead constraint management, they kind of use the similar type of information. So this contract that we had for ANM, it also would be used by this one. The only difference right now, it doesn't use MOL at this version. We are working on this one to use this look ahead also uses MOL that made order list that we were talking yesterday. Why? Because I think most of the companies are more interested in that ANM because they want to send real-time data. This is kind of new because the devices need to get that schedule that we were talking yesterday, how they get a schedule, they have this IEEE 2030.5 and it's the complexity behind that is like most of the companies probably I don't know, probably it might be the case for you as well. At the early stage of project, maybe you can use it maybe next year or something. I don't know. So this is the high level. I think probably I don't go through this because it's kind of same things that we had before. Just to refresh your kind of like, this, I think I felt this a little bit like complicated sometimes. So what is the flexible contract, flexible consumptions, grid services? Flexible generation means like the company tells you, okay, this is my maximum, but I can reduce up to here, and you can tell me where you want. So that's basically kind of curtailment. Same for consumptions, the same way. So you can just say, okay, I use always 5 megawatts as a maximum, but like I can have some flexibility to reduce it, like maybe to 3 megawatts. So between 3 and 5 is the play. You can just tell me what to do. The grid services is the offered power, as we say, basically. So it runs it at, or it has a schedule. In this case, ANM is real time, but this one said, I have a schedule. I want to run my battery at producing 5 megawatts in the afternoon, like 2 a.m., 2 p.m. And then, but I have offer flexibility. I can, instead of 5, I can do it 6, or I can do it, I don't know, 3. So that's kind of offered active power. Okay, so yeah, I don't need to describe this, I think, because I did it already on the other day. So what is the output? So we have something called look-ahead dashboard. So it shows the worst case results as like a dashboard for everything. Then when you open that, you can see the trends and stuff like this. For this one, I go to the software itself to show you some stuff, and then we might come back.
So it's like some kind of the future load flow with the DRM, except the MOL list. I think so, isn't it? So you forecast data and run clock load, right? And consider for the DER, set some schedule, and maybe you can send to DER to reduce the over limit or something like that.
Mm-hmm. Yeah, so this is the look ahead dashboard. Okay, so I'm on the root. I chose everything here. Just a note, like sometimes if your forecast is wrong, you get these kind of crazy numbers here. So this Montana sky, it has some problem. I think on purpose, not on purpose, let's say. It's good to know that, yeah, if you don't have the good data, you might get wrong results. And these are like, okay, overload, okay, 277, and this is reverse flow. So, okay, I go to maybe one substation, just see more information there. Okay, I go to the substation and it only shows the feeders and a transformer area specific to that one. And then if you open any of these, you would see the demand. So this is the demand. This feeder doesn't have any flexibility. It doesn't show anything here. There's no element that you can play with. You can only, in this case, use it for monitoring, right? You can open look ahead report as well here. So you can go to, this is the 4-hole substation. So the other thing also the switching, if you have a switching plan, you want to do some switching in future, you can use it. I guess that is something. And let's go to one feeder. So here is this feeder. All right, so then like the value goes up and down in the feeder head level, right? So this is like Q and this is P. Okay, so you can see this, but it's kind of like similar to what you get in forecast. But what is the difference here is that you can see the areas that is a critical on service transformer with red, and violations on sections on this red with like kind of like half color. This is critical violations and this is normal violations. What is the critical and normal? Let's go to one element. Maybe I can go to this a report. Okay, so this is graphical view and this is just the violations overview. So it says this transformer is overload. Okay, let's go and check it out. So this one is inside this. You could go to internal view from this. I just deliberately kind of like, you could go here as well, you know, you don't need to do it twice. Like I just wanted to show where the network is and then show it here. So this one, just to get an understanding of like what's happening here, I just turn on S from real time. Remember we had rating and this over 4 levels that we have. So normal, high value, and critical. If the calculated value is more than critical, it marks it with that color there. Yeah, it's a critical miss. And then if it's more than high, and high, so we have 4 limits, right? This one is more than the normal. This one is more than high. This is then more than high.
So this is the time step that will cause the overload.
Yeah, exactly.
Very cool.
So this is okay. You get a lot of red here. Yeah, so you got actually a lot of red here. So I think the first part is here, and then it becomes like this one, like a kind of a yellowish, and after you see is 12 a.m. is just stops, right? So 12 a.m. Sorry, just here. So it's just normal, okay. And there are 3 pages here. So it was not just one page, 3 pages. So I think you can sort or filter or whatever you want to see here. Let me see if I have already a filter, but yeah, I think if you want to use this system properly, it's always good to have some predefined one. Just, yeah, so this is the different times. Yeah. And maybe these are just because of tuning. Maybe this is okay, but like you need to have the wrong data, so I might call it like that. So
what is the system's suggestion for those violation? Like
what it does,
we do,
what we should do. Okay, in some cases you can't do anything. Because if you don't have any DR close to this on the disk, you cannot do anything. So it stays like that. If it was like let's say a section that it was overloaded here, let's say, yeah, I don't have an example in this one, but like, yeah, if you have a battery and then that section is overloaded, it tries to send a schedule to that. But this lookalike, this is just monitoring. So that lookalike, I will explain it a bit later. So, okay. So for this one, you see, there's nothing even on the feeder, right? So, let me go. Let me see if I have an example. We can do something. Okay. This one is, I'm back to the lookalike dashboard. So these are the limits that we can set. So this is demand. And these are time that we have flexibility. You remember I was showing to you that, okay, we have this table, you can say I have availability from this time to this time. So this particular asset has flexibility between 9 a.m. to 4 p.m. Okay, and because of that, it also allows demand decrease up to 1056. That 1056 is this value, okay? Because right now, this shows the current time. If you run it like probably after this hour, you don't have that flexibility. So it says, I have this flexibility. You can then, okay, send some commands to me. So then that commands are either based by this look ahead flexibility or dynamic operating limits. Let me explain this one. What those mean properly? I think I need to go back to here. I forgot about the lookout profile. Well, because you asked that question, maybe do you want me? Let me see. I have an example. So what happens? Yeah. So you, for example, that lookout flexibility. Let me see if I have like some explanation. Okay, so it has this like mode that you can turn it off, semi-automatic, automatic. Or look at flexibility, it sends the set point, like a schedule. Like it sends one value over the time, so okay, you have this flexibility, 1056, tries to bring this down to this with some kind of bandwidth. Yeah. So it checks that data and gives the schedule, sends it like I was showing in the block flexibility, right? Similar to that. The second one is when you have the operating envelope. So you can tell to those customers that you can run between these two. So those two also would limit, right? If, for example, in this case, if you have load higher than this, you push the higher level down. So they have something in the plan. Let's say they have planned to run 5 megawatts, and this delta is, I don't know, let's say it's 700 kilowatts. So 5 megawatts minus 700K, it would send like 4.3. So I said, okay, you just can run over 4.3. The results is kind of the same, but what is the difference? The first one is kind of set point. They follow that point, but the second one, instead of 4.3, they might decide go to 3 or minus 5. They have a range to play with. It's not a set point. So the main two difference between these two is that. And okay, let me see if I have. Okay, I will explain about the rest, but okay. It will show something like this. So yeah. Calculated demand decrease. So say, okay, at this point, do this, decrease your demand for this. So this is the flexibility. You remember from 9 o'clock to 4 o'clock, I had flexibility, this green one on the first page. So you can say, all right, but that example, here you can play through. here you can play this. So you can basically here you say, uh, uh, how much to decrease, right? So it's sending a command for base points at different values. And in the display, it would also shows it like this. You know, here, it's just below my name. Fine, that's why it says, okay, play what you want. And here, it is to bring it down by this much. And therefore, here cannot do anything, right? You can, but like at least make this closer to the limit that they want. Maybe the operators you get like some kind of like you do some other things like I don't know, drop it lower or something. Or maybe this limit is kind of a soft limit. Maybe you want to push it to there, but even if you don't get it, that's fine. You know what I mean? Like might not be just part of this something that you prefer to have.
But what if we change a little bit for the contract, like we have a battery can run at maybe beginning of the 9 a.m. right? But it can like operate at the 8 p.m. So what like what's the schedule that we choose for like the optimization and send to the battery? Because if you send those schedule for this duration is maybe good but not good, then choose the duration. Do you like understand what I mean?
Because so let's look at this at 10 a.m., 10 p.m. So you have this schedule.
Yeah, this
And then here you cannot do anything, right? So, but your battery says, okay, I can operate for you here. You already send this schedule for it's tomorrow.
yeah, I understand that the yellow is demand, right?
Yeah.
So what if the battery can run from 9 a.m. to maybe 9 p.m. but their like energy just can inject to the grid just around 7 hours only, for example, 7 hours for this duration. And this can be used from 9 a.m. but for better plan, they maybe the system will send the schedule from maybe 2 p.m. to 9 p.m. because it will reduce the peak of the demand better than this duration. So what if we change a little bit for the contract?
So I kind of get what you mean. Like you don't want to be, okay, so you are saying, for example, this is high demand.
Yes.
You want to basically battery play here
Yes.
to generate. So in this case, because this application is for constraint management, it's based on the constraints. Maybe this example, think of your battery was allowing us to play here. So it's the green part was like more, right?
Yes.
It was up to here. And then the operator can say, all right, is that causing problem for me? Where it caused a problem for me? So if this red line was higher and this green line was instead of this hour, it was up to here, the same thing was happening here. So the red line, but like is for mitigation. So if here, when you select this one, it should have a reason, right? If basically causes problems, so all of this cause problem, right? If really this is the problem, maybe your red line would be here, right? But only then you would send command only on this part. So it's not going to be, you know what I mean? It's kind of like you have this physical constraint on the network you want to mitigate. If you cannot like do this, the second approach here is either shift the load, right, from one feeder to another feeder, because you can, if you can, one substation to another
I just
one.
confused that because your example is fire fixed with the from 9 a.m. to 4 p.m. So that's okay because it's the playing duration of the battery can inject the energy to the grid. But what if the contract can be spent and but the energy of the battery is just price more, so what the system will choose for the best schedule of the battery, like
This is not for optimization, it's for constraint management. It's the battery, so when we send a schedule to the battery should kind of like say, oh, I have this command, I need to mitigate this value like this. I get this one, let's say, I need to charge my battery prior to this one. So it's the task of the battery controller itself to be prepared for the schedule they're sending. So that's the whole point. Like, okay, you don't optimize them, they decide, but they know that they need to mitigate this, they have to kind of, when they receive schedule, they have to kind of charge their battery to make sure we can provide this loss. You don't do optimization for the whole, yeah.
right? But what if like our operator see, oh, the battery can play in the duration of time, but the system choose the duration, so can we shift duration like a little bit more than longer than the system choose for the battery?
So this is based on the contract. You have contract with the owner.
For example, we can
If
like
it's your-
change a little bit contract for the battery and play from 9 to 9, maybe.
Like you can put actually whatever you want as a contract. If really you can operate the battery between 9 a.m. to 9 p.m., you can put it. You can operate the battery whole day. You can also put this. It's not a problem.
Yes, but my question is if the system choose this schedule, right? For example, just for example, this schedule was chosen by the system already, and the operator want to shift those schedule to next 3 hours or something like that. Can I do that on the system?
Okay, after you create, it's like similar to the question you asked yesterday. If we send a schedule and we want to update the schedule, is that similar?
No, similar because this we don't we did not send the schedule yet. Right?
If it's
Want
automatic.
to see the schedule to maybe next 3 hours and the operator can see the not see edit the schedule before they send to the battery. It's not similar to the previous question.
So I would say in this case, you can, one option, I'm just saying a few options. One option is that, okay, you look, because this red one is by operator, defined by operator, right? This red limit, it can be defined by the operator, right? It automatically comes from like the limits defined in the SCADA, but operator can't change it.
You mean we have to like change the limit and
So if you move the limit a little bit higher and if you had flexibility defined in your database for the whole period, like instead of 9 to 4, in the DR registry, you say, okay, 9 p.m. or wherever it's basically you think it's near high value. Okay, so you put that one, and then operator can have a look and says, okay, this is going to be my problem, and I just put it here to mitigate that problem as much as possible. Then what you're saying is like optimize it for future. I know what you mean. We are discussing with product team to develop that one, but they want to probably next year probably they can put a new version 3.11. They might not do that optimization, but for this version that we have, it's just trying to mitigate the constraints.
yes,
Because for other customers, right, yeah, okay, they want to avoid this high load and because it's some elements is has a problem, right?
yeah, because in my situation is quite critical because if the battery can run in this contract, so you can imagine that if we follow the suggestion from the system from this hour maybe 4 p.m. and go to 5 p.m. It's immediately increase the demand for the system, right? If we follow the schedule from the system, right?
Yeah.
Yeah.
So one thing I want to also say, right? Let's say now it's 10 p.m. You send this schedule, okay? And then let's say in 2 hours or tomorrow morning you come and you send another schedule. The battery controller should use the latest schedule for plan, like for its operation. So let's say right now, yesterday you did it like this, and you the load change or whatever your operators change this limit, those situations you guys discussing. It will send a new one, which the green one is kind of here, and the battery should follow that. Should follow only the last schedule, right? Because the schedule is for planning, right? So if I receive a schedule like this and what on there, I know that I need to do this. I prepare here. And then let's say you send this schedule, but the mitigation is here. Okay, I change my planning to charge my battery later. So your use case, I'm just thinking. I think eventually you want to kind of like, do you have a constraint or not? Like, does it, why you put it, like, let's say 4,000? What is the reason? I think that's the question we need to ask from.
Yeah, the reason we raise this scale because maybe we want to like demand like more stable, like when we use the battery, because in this case, you know that when we use the battery, the demand will decrease over there, right? But to maybe 4 p.m. this will be a lot. So in this case, we will shift the schedule of the battery over there and the demand is more stable.
Yeah. Yeah, I know what you mean. Like the demand is like coming normally from like a constraint. So you have transformer, you said you had the problem on the transformer, right? Or sections, like let's say if it's from transformer, what you would do, so let me just go back to this. So, okay. So, okay, let me explain a little bit more. Probably it might solve some problems. So this is one feeder. Let's start with this one feeder. The colors here. This is the this is the feeder that I was showing. Okay. Is it using the state estimation? Yeah. Sorry, I think you see it's the value that does it uses the state estimation actually. Let me just put just load flow results for P only, just to declutter. Oh, it has 4 point. It shows 0 here, but like the calculated value, but okay. maybe, but I can use another one that has like a value on Texas, maybe. Okay, Texas. Yeah, let's use, for example, this TR. Here you have this limit, right? So you remember we were using this in the ANN. So when we open this dashboard, and if I go to here for, let's say, this 1.3 comes from the limit I put here, right? So I have high limit 1.3 minus 1.4. And this is because of, okay, you put this limit because you have some restriction on that particular feeder, right? And then, yeah, but then the operators use it. This one, maybe it's a kind of wrong data probably. Or I was playing with the system. I just put that 1.3, right? Let's say then operators can say, all right, this is the highest value. I want to optimize for this value, and it's about 3,000. You can put 3,000. Okay. When you write it here, so you see there you remove the yellow line, red line up to here, and then this will be impacted, right? So this will be one way to do this. Okay, so this is TR05, but like this one doesn't have a flexibility, but like me go to the PR05. PR05 is the same. So if I have this 3.9 comes from like a limit and the measurement, and probably again, I put some value there. In reality, it probably was not there. So it's, if this forecast is like around 9, 8 plus, okay, you can also see here. You can put 8,500 and it shows it like this. But this one is coming from the DR database. Operator cannot change it because you have a contract with the customer. So in reality, if you want to be looking after your peak load and your peak load is in the afternoon, I suggest that, you know, this data in the DR database, you change it to like instead of 9 to 4, change it to 9 to 5. And then your operator say, okay, I mean, in reality, our operator doesn't need to update this. It should be only impacting where you really have problem.
Your contract mean because maybe we can use them in the specific time, but we don't have to use them, right?
Yes.
In some cases, we don't have to use them, so your like look ahead. For instance, do you suggest to like use them to reduce a little bit the demand because of the contract only, right?
Yeah, because I would say you only, I think these are not set because yeah, we need to put the data here. So what I'm saying here, the red line is coming from restriction on the network, right? So if normally this feeder can handle I don't know, whatever level it can handle, you put it in this one. That's the right way. Sorry. Sorry, wrong button. So if in reality you put alarm limit here because you put 1.3 because of what? Because, for example, you have an element on that network cannot handle more than this. Yeah. And that will be automatically picked up by software and tries to only mitigate, send the command to the batteries when they're there. Because why? Because customers, when the battery belongs to another company, right? When they make a contract with you, you have to pay money to them. So you don't want to engage them when you don't need. right? So you only want to engage them when they actually want to fix your constraints on your network. So this product, load constraint management with these two functionalities of functionality, is designed to mitigate the actual problem on your network. So if you want to manually, let's say for this example, 1.3 is okay, or maybe 5 is okay, whatever, your operators would not change it here, but yeah, still you can manipulate it on this one if you want. So if they have some situations out of the constraints, so we have added some like extra like level of, flexibility for operators to, without changing that scale of value, to change it from here. So this normally comes from like somebody, when we override this, it's similar to what flexibility. Somebody tells them, okay, we need to mitigate this problem for this particular time. And it's, as you see, this is kind of a temporary, right? And it's overrides, like override. So it's just maybe today I do it like this because somebody told me, oh, today we want to limit by 3,000, or the bottom line normally is coming again, a call from a transmission company. Normally for them, reverse flow of -24 is fine, and that's why we put in the limits. Normally that's fine, but today they told us, okay, today I have, like for the next 24 hours, we have this problem. Can you just limit it? And it could be not for that feeder, it could be for whole substation or whole of this. You can you just you can do that at any level. I'm just trying to explain the use cases that you might need to, my user might need to manually update this one. Normally you don't need to, right? If you have your limits is correct in these two limits is correct, so you don't have to change it, and system automatically only will be engaged when it's necessary. Okay. But yeah, I understand the use case you're saying. Let's say this battery is your own, because I think it's not third party, it's your own, right? You want to see, huh?
We will have.
You will have those one. Okay, for those one, as I said, like in 3.11, we are developing some function, I think by end of this year or mid next year, I don't know exactly when it's going to be, that for good own, we kind of like prepare it as well. We send, we know that is going to be, they needed to be involved at this time. We send some schedule prior to this to make sure they're charged enough for that to be discharged. I know what you mean. Yeah.
Yeah, so far you all look at like person does not like consider the optimize of the dia with the duration they should engage or something like that, right?
This is basically designed for like third-party battery operators, because like in like US or Australia, or they either is people, they have roof solar on their top, they have battery. The way they do it, they tariff, like they participate in market. It's companies they doing it, not individual people. They are saying, okay, we have flexible battery, and they gave it to that aggregate. That's why we have this concept of DER group and DER aggregator. They give to them, okay, we have this much flexibility, and they make a contract with them, and they operate, and when it's needed, and only when we have problem really with some physical problem, with constraints on the network. And optimization is up to normally, like for example, if think of like battery at home, you have a solar, they have a schedule. All battery controllers, they have a basically program that when the solar is high, start charging it, and then discharging it normally is when the price is high. If they have tariff, so it's automatically kind of doing it if it's smart. If it's not smart, then even we just tell them, okay, just you need to cut on like this, but they should have a different smart process that when they get a schedule to drop in the afternoon, as I was explaining to you, they need to prepare for that so that they can follow that order. Yeah, I think conceptually, I think kind of we are almost there, but like if you have more questions, just let me know. Yeah, what we can do, what we cannot do. But I think that's what I'm saying, trying to say what we can do with this version, what you want. So probably not, maybe, yeah. Okay, so this one, I just give you some kind of like explanation how to use the software. So this was, I think in the presentation, you can put semi-automatic and blah, blah. It's the same for this and that. So both of them have the same approach, and then you can trigger it. So this one is fine. Okay, sometimes the user, they say, all right, I have flexibility, but for whatever reason, I want to clear, like I don't want to send a schedule during this time. It's kind of like a by exception kind of thing. So you can select the area you don't want to. So, and then like here, I selected this two time, and then I mark and say, okay, do not send a schedule in this time. You're happy, you can use the rest of the time, right? So this is again like something we have. Do you want to use it or not? I don't know. And like we have this kind of like fail-safe situations. Fail-safe situation, let's say a SCADA value is in bad quality, or your network is abnormal, and you don't want to send control on the abnormal network. So this may be useful when you have a SCADA base, because for non-SCADA base, it actually is network calculates it. If your topology is right, it calculates it anyway. And probably you don't need to turn it off. But like if in a SCADA mode, you're not sure about your like how it's gonna work, how it's gonna work, you can say, okay, don't run it in the abnormal situation. That's a kind of a flexibility we have. And this is critical section locations. When you select this, these are like measurements in your system. So this one, the first one is, you can actually locate them. So this one is, for example, here. It shows the closest measurement. And you can say, all right, consider this for my calculation. And you can say, I don't consider some of them. So here is just saying, okay, apart from the feed ahead, what other sections with measurements you want to consider? So this one is like, this is the name of the switch that is controlling that section, right? This is the name of the section. This is the name of a switch. Control fee, copy field. So that was when I was like basically, let me see if I locate from here. I think when you locate it, it shows the section, but if I just Yeah. Yeah, analog signal is not on the display. That's the reason it doesn't show it. Yeah, it's not in the display. So, but like it's analog signal. Like you can put yeah. So these are like analog signals, right? So they're associated for this one to the segment, but you normally associate it with the battery, with sorry, a circuit breaker or CT or something like that. Yeah, this one, I think, let me see signals. Yeah, they associate signal with this section. You could do that as well if you want. So, but this was the one that that's why I was a bit confused, very thirsty. It's on the section. Okay, so that was like this one. So where you want to select, and then here is similar to what flexibility. I have flexibility to decrease demand. Decrease demand is kind of like increase generation, right? Decrease demand. So that's my grid services. I don't know if when I was showing this DR contract. So we have 3 contracts for this element. One is the flexibility. We have flexible generation and flexible consumptions. So we have all those 3. So and I think that's pretty much it from this one. Let me just go to the. I go back a little bit to see if I missed. Oh, profile. I forgot to explain about the profile. So we have active network. Sorry, not active network model. Okay, look ahead here. Okay. So here, this is the master key to enable look ahead. Do you want model base or measurement base? Okay, so if you have currently I use model base for that because that's why everywhere we have violations. Or overload violation. The only thing I would say if you use measurement base, the only thing is you need historical data for all your devices, not just feed ahead. Right now, for this system to work, we just put feed ahead. But let's say you have telemeter circuit breaker with kilowatt in the feeder, like the one I was showing. If you want to use model base, we need to get historical data for everything. So it's a bit more complicated as well. Like not complicated, but you just need to give more data to us. And then here is where you say, okay, overload violations, voltage violations, reverse flow. So what is this consider measurement? So if you have model based, you can just use load flow results. But if you say consider measurements, like I selected already, it also uses whatever measurements you have on the system, which is good because it gives more information to the system and they can consider that. So I suggest to select that one. These are alarms for overhead, voltage, and reverse flow. Okay, so I only, when you unselect, that means it creates the alarm, inhibit, right? So inhibit means it doesn't do this too, but it does the first one. So if I go to the, I think we have a shortcut here. Do we? Yeah, alarm summary. So you see it creates this signal and says overload detected for this. And it has this 3 dots, which you don't want to have too many alarm lines in your system. It just like gives the like all of them at different times. So this transformer, if you remember, we had some problems with some transformer, right? and at this time, and it shows how much we're violating this limit. So it's kind of like, yeah, we don't want to get alarm limit to be flooded with like this, like, because you're going to get like, I don't know how many, like 20 and something like that. We just get one master alarm and then we'll get it there. And this one, because I was running on the TR05, it just for this TR05, I can just change it to anything as well if I want to. So if I say contain, so it's kind of like for all of that substation, but it's not just power application, it also shows a SCADA one. So if you want to see, for example, I just want to look at the look ahead problems, you see this category here. So maybe you just copy this one, copy field. Then here you can say category. And I can save this look ahead overload. TR maybe, I don't know, probably I need to remove TR, but okay. I just, next time I think from application, if you go, it automatically puts some filters, but like if you, for example, next time you go to here and just go to alarm and filter, my filter is there. So from the master alarm that it shows every alarm in the system, so I can quickly bring up my alarm, right? So it's two-way for the same thing. Okay, so this one is power application setting, is not profile, but then in power application setting, there is some setting for look ahead, what time does it start, how much the interval, 1 hour, change after topology, change after near time forecast, because when near time forecast runs, it's good to run this look ahead, switching approval, and so why switching approval? Because like let's say you have some switching in the system scheduled to be done in 5 hours from now, it will consider that. And then, but this was triggering when you approve it, this is to use it or not. Because in your system, probably if you don't have switching plans written, so there's no need to select that, but it's fine. That is for the card itself, and physical state management, like how long you want to share it. It's 24 hours. You can speak for 12 hours, 48 hours. So use for things like cluster management time to start time next full hour. Like let's say at 11, 12, 13, so that is like this. That's like the big problem, like and then not a big matter. Forecast error in the calculation. So forecast, it just also tries to suggest what would be the potential errors, and it makes it a little bit like you select that, it adds like a make it more conservative. Let's say you forecast 4, so it calculates 4, and the error is like 0.2, 4 point plus 2, and 4 minus 2. So it depends on like which limits we are looking at. So it just make it a little bit more conservative. Maybe you can select that one. It's up to you, but I guess we need to see the results of forecast and see what we do. Okay. And profile assignment, like any other applications, we have profile assignment. You can have different profiles for everywhere. I guess we explained this one already, and we explained this one. Yeah, there are lot of curves. When you execute this, they're gonna be like, you see those like a lot of colorings here. So I put the explanation of those coloring. It's in the functional specification, but I copy pasted here. So just to quickly like the high limit and low limit is quite clear. Yellow is demand. Yeah, okay. And they don't need this. So but the one that is difference is demand decrease and the schedule increase is the impact is the when you have results. I think I explained this one. I explained this one. I explained this one. Explained this one. Clearance I did. And this one we did. Yeah, that coloring. Okay, so that's for, again, this one I explained, like, okay. Yeah, this is the editing that you were saying. It is possible to edit the values after it's created. So here, for example, you see they edited this one, and it shows it that very different colors manually. Yeah. And this is dynamic operating limit. So dynamic operating limit, as I was explaining, it has two lines. So what is a maximum demand is per contract. You have like a maximum demand, let's say 5 megawatts. And firm demand is per hour. Like you get per hour, they say I have this much flexibility, and it is in your schedule. In the DR database is in the schedule. That's the firm demand. And what is like you can, what the Luca had UL calculated is calculated. So it has a lot of color here, but yeah, I think for most important one is this is the output of the software. And these are flat. It is not turn off. This is generally flat. This one is from registry. A bit of explanation about what is that. Okay. Yep. Continuing, the same thing. It's just minimum, just maximum. And yeah, similar to the other one. These two very similar to each other. The only difference, it produces two output basically. And yeah, here similar to the other one, you could edit. You could edit the calculated one, yeah. But this is the firm. I mean, this one maybe is a good one. So this is the DR registry. You get this, right? And this is what this software calculates. And I was saying maximum demand is generally flat. Okay, events, I think I didn't show it, but I showed alarms, but okay, I can quickly show the events as well. If is event, so this kind of shows like if we sent a maximum demand or minimum demand or something like this. So it's just anything like we did, it will show here. Yeah, so that is kind of like what I had to present. But then in the schedule, we had like some spare time. I think we were faster than what we thought. So we had some summary or question and answer, but we did like interactive, like, but again, if you want to, we can continue in the afternoon, any topic that you want to talk, any questions. Or one thing we suggest, if for any of these, what we can do we can put some configurations that we think you might need to start with as a document, and like, because all of these applications had some like little configuration, like profile, blah, blah, so what to start with. I can provide that one in like a document, send it to you. And because I understand right now, you cannot say, okay, this is good or not good. That's to start. But then you can always go to the document to see if what does this mean, what you need to change, and you can always ask email to us, like if something is not clear in document, or we can ask also product center if you don't know. So you have the documents that I was showing to you, like any of these documents that you are missing, just let us know. So
Yeah, we are looking for the document, but I think we should like.
do you have, for example, this forecast, all of this topic? Just please check that if you. I think we have some document for tuning. Maybe it's not there in your net model, but do you have access to a Schneider Exchange?
What?
A Schneider Exchange is like a website. No, we don't know. Okay. It has like more like documents that we sent to you is all already there as well. So I was like, if you want to see something out of DERMS, let's say you want to see, I don't know, OMS, how OMS is working, how switching things working. If you're just interested, you have more spare time to spend.
Naturally, we're looking for some like more specific document, like the process. How could we like query for more data from historical server for table? What does this mean? Or how could we link table A to table B or something like that for some specific purpose or something like that? Or maybe we can like know the process. How could we like for OTS network? If we do something wrong in the OTS server, could we resynchronize back from the production to OTS for something like that? Because all those documents, I think, just focus for explain the function from DERMS, from ABMS only, right? How to use it, but some process.
Yeah, okay.
Those document like that.
Yeah, we can provide you if there is any document that we already have, like for example, for tuning, I guess we have one formal document that shows those processes. For troubleshooting, I think what you're saying is troubleshooting.
Yeah.
I think I need to ask Faris to see what kind of like documents we can provide as some of things, to be honest with you, like I was showing to you this morning, like it had an example of SQL, for example, in that forecast already. So maybe in the function specification, sometimes you have some stuff, but no, I think you cannot have every information there. So like, but we have, like, for example, if you want to interested in the database, I see like you have asked a lot of questions in the database. I think, let me see, do we have like on the system, sometimes we have some I can give you about database. I think we have like some explanation. Yeah, we have some explanation of a schema, a database schema, and I will try to find that and send it to you. I think maybe maybe Sirna is the expert on that one too. Do you know where it is, or if you don't know, let me know. Just I don't know. Okay.
Again, because I have it for
If-
3.9. I have to try
Three,
to
three, 10. Okay, even some of them are in the system. When you install the software, it is let me see.
It's you have file something like that, but I'm file is default. I don't know.
Okay. Yeah.
So I think that maybe I can list some like what
Your
we
wish
need-
list.
What we need. Yeah.
Your wish
And you
list.
can consider that you can provide or not, maybe.
Okay. Look, I mean, if any document is official, we are very happy to give it to
Because,
you.
yeah,
Yeah, but like as far as it's officially available, yeah, we will try to give it to you. Some of them, like, remember I was showing to you the you can press F1 and see like some information there apart from the functions, but it's different. Like for example, for database, I know that I was working in the previous ones. I had like a document. I will try to see to have this, but some of the processes kind of like maybe sometimes you need to ask us. I just want to be kind of like you can always ask us, okay, we want this and we want that, and we try to be as helpful as possible, of course, and if we can provide information to you, I will put any SQL that I wrote today for you, just with some little explanation. Just you don't need that because like there are 1 million tables there. you cannot use that and easily understand. Maybe you can if you can just explore a little bit, you get some understanding of but I know but you also are requesting there is not one document CHM for database. I'm just after that, so I will search for this and find it for you. Maybe it's in the
okay, this is the last topic for the lesson, right?
that was the last topic. Yes.
Yes, and I think for after lunch, we can like discuss more about the requirement for this project, because I still like haven't received any confirmation from Green Infra. Yes, and
Okay.
so I don't know that it will like can meet all of the requirement for this contract, or maybe we can discuss after lunch and some like what we need for the document, and you can consider that you can provide it or not. So I think so.
Okay, the only thing, the contract, I guess maybe I'm just thinking maybe we need Funcsil because normally project managers look at the contract, so I have some limited information. But I'm not sure if we can go everything about the contract. Let me just ping him because I think he was today, so I had some meeting and maybe,
Yeah,
but he's available probably tomorrow too, if he doesn't, I think he's the right person.
If they have some meeting, so we can like just discuss about the documentation only.
Yeah, but
Yeah.
let me call him what time he available. Maybe we can have some slot for online.
Actually, maybe we can discuss next week on online meeting, because we have to like invite the written program, right? So,
Yeah,
for the learn.
we go through to see what we have in the database, and how we can help you more.
Okay, we
Yeah.
list out some like what we need for the system or the process and we
Ah,
can
okay.
discuss after lunch.
Yeah, no
Okay.
problem.
Yeah,
Yeah,
and
that's
we
okay.
finish the lesson for.
Yeah, exactly. And anything else that you can, anything technical you can ask.
Okay.
Okay.
Money is functional. Um,
Money and contact.
but yeah, we can,
Okay.
we can try. I can try to explain.
Yeah, thank you very much for your lesson.
Thank you. Thank you for also being patient. It's kind of like sometimes something doesn't work, sometimes I don't know something. So yeah, always like the good thing about visiting customer is you get good questions. Sometimes, most of the time, you get have very good questions. Okay. I follow up with the questions that you had asked yesterday. So they told me we analyze and come back to you. I think that hosting capacity may be something wrong. I need to just double check. Maybe I did some configuration need to change or something.
Okay, thank you.
You don't have to